Hello everyone, I am Hongrui Zhu. Today I'm going to analyze the time complexity of merge sort. I'm going to do it intuitively instead of using Master Theorem. And our goal today is to show that the time complexity of merge sort equals to big O of n log n. So first of all, let's review what merge sort does. Merge sort is a divide and conquer algorithm which divides the array into two parts, and then it recursively sorts the left and the right part. And eventually, it merges the two sorted arrays and get the final result, which is a sorted array, right? So, and the merge function here visits each element exactly once. So, the time complexity of this function is just big O of n, right? So we can then write the time complexity of merge sort as a recursion here. And this part is just t of n over 2, which is the time complexity of this problem. And c of n is just the time complexity of this merge function. Is that clear? So, and we cannot forget a base case, right? The t of 1 is equal to theta of 1. Which should know the situation where the array has only one element. Okay, so from here, if we're using the Master Theorem, we can directly get this equation here. But we're not going to do that. I'm going to do it more intuitively. So let's expand this problem until we reach the base case. So each time we divide this array into two parts, right? Each of them has the size of n over 2. And in this layer, as can be seen from this pseudocode, aside from these two subproblems, we are doing an actual work regarding this merge function. So, since there are two subproblems, and each subproblem has a time complexity of n over 2, the actual work we do here is actually c times n. And similarly, in the next layer, we have c times n over 4 times 4, which is also c times n. And as we continue, we can find that in each layer of it, the actual work we do are always c of n. So we'll divide n by 2 until we reach 1. And the base case has the time complexity of theta of 1, right? So this part gives us a time complexity of n times theta of 1. And this is exactly theta of n. And let's analyze how many layers are there in the tree, right? So we're dividing n by 2 until we reach 1. So they are exactly log n layers, right? And we times log n by the cn here, which denote the total actual work that we do regarding merging. So, and then we add theta of n together with c times n times log n together, and we have a final time complexity here. So what we are going to do is to ignore this term, because theta of n becomes not so significant compared to n times log n as n becomes very large, right? So the time complexity here is just big O of n log n. And finally, we have proved that the time complexity of merge sort is just big O of n log n. So we do it intuitively without using Master Theorem.